All right, everybody, thank you for coming. It's the first session after lunch. I try to not put you to sleep. And I was thinking about this picture. I was walking back and forth. I got it from my, the company, the marketing team gives these pictures out for presentations. I was looking at, the people are looking at the phone. Let's talk about how much attention span. Everybody's on a phone these days. I'll try to keep it interesting so that you don't have to go back to your phone. So if it's boring, I know what's going on. OK, so I want to talk today about self-service. And I want to talk about how we can achieve that using Tableau. So let's get to know each other a little bit. How many people are using Tableau right now? Great. How many people are using Tableau for some sort of self-service? Awesome. How many people are using cloud-based data platform? Awesome. You're not supposed to give that. OK. How many people are using aggregate tables? Only 1, 2, 3? Cubes? OK, more. Data marts? Awesome. OK. I'll tie all these things together, OK? I'll tell you how all these things work together. There's a reason why I ask these questions. It's about learning over the past decade. What I've learned as I was trying to solve this problem of self-service. Let me quickly explain what I've done so far. So right now, I'm heading analytics. I run the analytics team. I have a couple of folks from my team here as well. So if you have more questions at the end of the session, you can always reach out to these couple of guys who are here. Well, I run the data science, the business intelligence, and analytics there. But I've been working in the field for more than a decade now. So, and one of the things that I've realized, while I've used a lot of technology and tools to try to answer these questions, help people to get insight either through a report or a dashboard, there was always something I was missing. The thing that was missing is the learning. Like you create these dashboards and give it to people. They use it. They answer those questions that they have, and almost it stops there. Because the dashboards and the reports that we were providing, I'm talking about maybe about 4 or 5 years back, we had other tools and technologies out there. And these dashboards and reports always answered a set of questions. And it answered pretty well. But again, the learning was always not there. Not always. It was there, but not always. Because you couldn't answer the next set of questions that you had. When you get a result, you look at a dashboard, oh, I'm learning this and that, and then, oh, what about this? What about that? And these dashboards and reports that we created, I think have failed my customers where they're not able to get the learning out of it. So that's what I'm going to talk about. And self-service means different for different people. Don't get me wrong. Data democratization means different things. It could be an engineer going to a Spark cluster running a Spark query. That is data democratization. But I'm focused more around executives, product manager, people who really don't have the time to go into these platforms and write a query and to get insights out of it. So I'm focused mostly on the end users, so in terms of people who have less time, who are on mobile phones all the time. Those are the kind of people I'm targeting right now. OK. So there are a couple of things I want to talk about here. One is Tableau. Of course, I want to talk about how we can do it in Tableau. Second, I want to talk about repeatability. I mean, that's one of the key things I want to talk about today, and why repeatability is one of the most important things in self-service. Because I can go to a dashboard, get something, a report, I can get something out of it. But if I cannot get the same thing out of it in 2 months down the line, my self-service infrastructure broke down. And if you have to go back to an analyst and answer this question, it broke down. So keep that in mind. So with that said, I'm going to get in the demo right away so that I don't put you guys to sleep. So I'm going to get back to this. All right. So keep in mind what I'm going to show. This is the end product. It's from a dev environment, but it's an end product. There's a lot of things that has to happen until you reach there. So I'm going to show what this is going to look like at the end of all these things what we have done. Okay. So as a user, this is a desktop environment. The same thing is available for users who are using web as well. They want to have answers to certain questions of their own, or maybe it's a link that an analyst sent to them, and then they want to have more answers. What we have built is we have built these data sources, and you heard about the certified data source, things like that. So we've been thinking about in that similar way for the past few years. So we have built these data sources where people can do their self-service, answer these questions on their own. But the biggest problem we had with Tableau and other technologies out there was how much data that we can get into these systems. And, last year in Tableau conference, how many guys were in the Tableau conference last year? Cool. You've seen the demo for Hyper at that time, right? A couple of billion records. I think they were showing the live connection and a couple of billion records. That was kind of cool at that time. And then we were waiting for Hyper to happen. It's happening right now, but what I'm trying to say is that's the way the industry is going. So it's not about few millions of records. We don't have to have aggregates built to answer these questions. So keep in mind, that's the first thing I'm going to show. This is a dev environment, but still I want to show you guys this. I'm talking about the self-service at a very large scale. So this is basically I'm finding out my data source. One of the most used data sources is the traffic data source that we have, and I'll talk about this. First, I want to show the volume. All right. So I'll quickly do a. I'm going to pause it here. So we're talking about 5.5 billion records here. And even though it's a count star, and I'm getting into it, even though it's a count star, just imagine a count star came back in a few seconds. It did not even take that much time, but it's a live connection here. So keep this in mind. This is what you're talking about. At scale, we have a data source that connects to a live connection, is giving you results. So I'm just setting the stage, okay? I'm going to keep going here. And I'm going to talk about the use case that we applied recently and how to use the data source and do it in a self-servicing way. All right. Okay. So Edmunds.com is a website, and I'll talk a little bit more about it later. I want to make sure that you guys get to understand the concept. We are a website. We have about 20 million people coming to our websites on a regular basis. There was a time over here. I made this video last Friday, so I didn't have to do a live demo. And if something broke, I didn't want to be there. So you see this dip over here. People were curious what happened, and even if you look at the timelines, any guess what happened here? Hurricane, yes. Yeah, so executives are looking at it, oh yeah, hurricane happened, that's why everything dropped. But and this doesn't stop there, okay? And this is a very normal situation that people in the analytics world, people tend to, oh, that's what is happening. It's a gut feeling most of the time. And there's nobody, and you go to an analyst, okay, can you confirm that? That's the culture that we have. And we are what I'm trying to tell you is that it doesn't have to be that way. So I'm going to talk about why somebody's gut was wrong. It was not just a hurricane. So I'll talk a little bit more about that. So I'm just, here what I'm doing is, again, about 5.5 billion records. I'm doing this on the fly. I'm just selecting that record where the dip happened. And keep in mind, when the initial analysis happened at the lowest point, we didn't have the bump back up, so that people didn't know what's going on. I'm looking at the lowest point. So it's probably over here when I was looking at this. OK, I'm just adding some additional filters where these are the products that we have. So don't worry too much about it. But what I'm saying is that these filtering, aggregations happen, all these things happening on the fly. And keep in mind, this is the count distinct value, by the way. I don't know about count distinct. I guess I've used count distincts. It's a very computationally heavy query. And I mean, 5 years before, I would never be able to do this with any of the system that we had. OK, I'm going to take a pause here and explain a little bit more. So over here, you have the Harvey, you have the Irma, but the funny thing is that it's a big drop. There's a real drop over here, and people didn't know. And the question was, is it all because of hurricane? That was the question. And a general tendency to say, oh, that's because of hurricane, and we want to make sure that was happening. And we didn't want to put anybody, the analyst, to go run these queries on the Spark, but we want to have people like, so this analysis was done by one of our executive directors who run the traffic analytics. He's not an analyst. He's not like a developer. But the thing is that with this, he was able to do this on his own, sitting with another executive side by side. So that was a win in my mind. That was self-service right there, without asking anybody else. So I'm going to go a little faster so that I can get to the point. So I'm talking about the two dips over here. Again, that was a point where we were looking at it. So there was a big drop happening, and we didn't know what was going on. The next thing you do, because it's a hurricane, and everybody thinks it's Texas versus Florida, want to make sure that's what is happening. We split the data by state. Okay. Let me take a pause here. The one on the top is California. And see, in California, you see the drop as well. You see a drop as well. But nothing really happened. Is it like we are all Californians are worried about hurricanes as well? I don't know. So that was yeah, Texas there was a drop. You see a drop here. That's the Harvey. And it's slowly recovering. Made sense. But it was the same kind of pattern in California too. So we had to wonder why that's happening. And then obviously Florida, it's a huge drop. Makes total sense. So definitely these things mattered, like in the Harvey and Irma mattered, but the story doesn't end here. And the thing of what I want to talk about is, if there was a dashboard, we had to create a dashboard by, let's say by state. They would see some of these things, and they would not ask the next question. We stop right there. But when you have we're connecting to the live data, and again, it's not just live data. There's answering these questions fast. We don't have to stop there. We can go to the next steps, and that's exactly what I'm going to talk about. This would have missed out, or we would have been going to an analyst to get the next set of insights if we didn't have an environment like this. All right, we're going to go back again, look at what's going on, and we are going to split the data or the visitors by the kind of traffic. So we have organic traffic, and we have paid traffic. Trying to figure out where's the drop. If it's mostly from hurricane, we're looking at traffic drop from organic. If it's a paid traffic, we'll actually see there are some other campaigns going on, okay. Oh yeah, this is another thing. I'm sorry, I missed it. So this is another thing. I want to understand where the drop is coming in terms of browser type. That's the one thing we always check. Did we break any of the releases with the product? whether it's a mobile product issue or things like that. So we always check this. Just, fast forward a little bit. So we saw the same drop happening across all the browsers. Now we've split the traffic by paid and organic. All right, there you go. There's the first real clue of what's actually happening here. This big drop, that drop is where the problem is. It was not organic. It was a paid marketing drop. And there's the culprit. There was a campaign that was running that actually did not get the data, did not get the clicks we were paying, but the clicks were not converting to visitor sessions because we had a product bug in our website. So people talked about, going back to my deck, and this is basically the demo. I'll go back to my deck right now. So the learning was, sure, yeah, okay. The difference between a dashboard and a live environment, a self-service environment like this, is that people can ask more questions. It doesn't have to stop at the end question that define a dashboard, but you can start to ask more questions. You send a link to the people, let them ask more questions so they can get to the learning they really want to get. So I'm going to talk about this. So how do you get to this particular place, right? You saw how we use the data to answer these questions, but how do you get there? So I want to talk about several things. I want to talk about how to engineer the self-service environment and the challenges that we faced and why it's important for us, right? So I'm going to get through some of these things. I'll talk about the admins, what we do a little bit, and how Tableau comes into the picture, and how to scale it, how to make it repeatable. That's what I'm going to talk about. Okay, admins. If you have not used admins.com, we are a website to help people find their perfect cars. We have a lot of consumer. I was talking about 20 million people come to our website. Our product teams, we support our product teams to understand what's the consumer behavior. And then we support the OEMs and dealers. Basically, we work as a platform to connect these consumers who are interested in buying a car to dealerships as well as OEMs. So that's what we do. In terms of BI as a challenge, I think this is an area of opportunity. We have been getting the data, ingesting data into our systems. But there became a point where we're not getting enough value out of it. Only certain people are getting value out of it. You have engineers who have access to, who have this ability, skills to go and write the queries. They can get access to it. We have a platform. We have a big data platform. We have certain analysts, data scientists. They can get access to data. But, the value was not there because half of the people in the company is still not using it. The insights were all coming from the one centralized team of about 25 to 50 people, and that is not scalable. You are basically putting a big roadblock in terms of how to get value out of data. So that is the challenge. That was one of the biggest challenges that we had. That's the reason why we had to think about answering these insights, analytics, more in a self-service manner. And one key point I want to mention is learning is the most important thing before innovation. You have to experiment so much, and especially people on the website side. You've heard about A/B testing, things like that. Experimentation is key, and more you experiment, more questions you ask, faster the answers are, you learn more, and you learn more, you get into the innovation mode, and that's our philosophy, in terms of how to use analytics. And another aspect to this is the decentralization. As I was talking about, we don't want these insights coming from few people. that is very restrictive. And we want these insights coming from all over the place. We want decentralized analytics. We want to push these specialists into different teams who can actually answer the business problem. We don't want to solve, like, analytics should not be just about answering certain questions. It should be about moving the needle. What is the business value that we can get out of answering these questions? So these were the kind of things that we're thinking about when we redesign our platform to get where we want to get. The big problem, we have a lot of data. We have a lot of action, user action. A lot of people come to our website. 4 terabytes of data. We had everything in Redshift. But again, in terms of democratizing it, we were not able to get people to use it as much as we want to. We have a lot of dashboards. And I'll talk more about dashboards soon. But we had the big problem. The problem at the bottom of the screen, the 8-second attention span. We were not able to get people to use most of these things. That's because, one, performance was a problem. Like, everybody has smaller and smaller, shorter attention span. And anytime we say, OK, go use the data, anytime we said that, they will try it. They try it for a few times and say, oh, my God, it's too slow. And they'll not use it. So that kind of slowed us down in terms of getting the data democratization. So what we did is, a couple of things we did. When we talk about decentralization, so we have this analytics with a centralized team. So the first thing we did is we actually put them all across the organization. We created something called squads. We push people. This is basically you have data scientists. Data scientists be engineers, and analysts. We push them to different squads so that they're basically integrated within these different smaller product organization, or in a sales organization, or marketing organization. So that really they are evaluated by how much actually is getting value to the company. For example, if they are part of the SEO team, it's not about answering SEO questions. It's about, oh, did we get more SEO visitors this month? That's the goal for all of it, not just analysts, but engineers in the team. Everybody has the same goal. That's the first thing we did. Second thing is the infrastructure, the architecture for how to get the data. And I want to talk a little bit here, because the reason why we reached that high scale architecture in terms of self-service is because of this. I talked about how many people are getting in the cloud. This is the reason why it's very important. And I have to say that you have to, the decoupling the data layer and the compute layer is the key to this kind of performance. Let me ask you this. How many people are using S3 as data lake? OK. It doesn't have to use S3 as data lake. I'm just explaining. But that's one of the key things. You need to have some sort of data lake architecture where you're putting the data there, and then decouple. Like, when you talk about Redshift, as about Netezza or Redshift or some of these MPPs, that's a box. That's a server. You buy a server, you push the data in, and then you analyze it within as a box. Now, when you get into this data lake architecture, you're opening up those walls. You can use anything you want. In this case, we use Redshift as a compute engine. We use Intrana or Spark. We use several things as a compute engine. But it's completely dependent on what your use case is. If a self-service use cases, maybe Redshift is not the answer. Maybe there is something else out there. For data science use case, you use PySpark or you use other things. But as long as you're decoupling the data layer, data from the compute, you have an option now. That was not there before. That's the reason why now we can get into billions of records and still do count distinct of users. That was never possible before. So one of the things I want to talk about, you guys are going to get back today, from this session at least, I want to get us, you have to start thinking about this as a potential strategy for the future. Tableau, I have to say, this is one of the best things happened for the company in terms of analytics. We had several other tools out there. We used it. Never got adoption. But Tableau definitely is a game changer. Just in terms of, your biggest change is this, the powerful storytelling, where they were able to use, dashboards and, you connect to your data. I'm talking, this is a pre-era, but still there was a lot of storytelling going on. There was no self-service, but still the people are creating dashboards. We got a lot of adoption. And then there's a lot of good stories going on. And executives, the whole expectation changed in terms of what analytics was. But and the thing that happened over time is when you have analysts doing these kind of dashboard and storytelling, you have now problem in terms of are they using the right data? You have the quality control problems. Are we using the right rules? So those were the kind of questions that was coming up, and we wanted to solve this problem along with the self-service so that people are looking at the data the same way. So I'll come to that in a second. Quickly want to show the adoption. We got an amazing adoption with Tableau. Some of these numbers might look small, but if you have been in the BI world, you know how difficult to get user adoption. To get 100 people using on a daily basis for such a small company as ours, it was not easy. Okay. So I just want to quickly show what happened in Tableau. We started on desktop. I want to say if there's anybody in this room still thinking about getting into Tableau, I just want to raise hands. Anybody thinking about getting into Tableau? Yes. The best thing to do is to get a desktop license. Start with the desktop license. That's where people get excited about it. That's exactly what we did. We had a couple of our analysts got desktop license. They started using it, connect to your data, and started visualizing. And then it started to explode. We got a lot of adoption. A lot of dashboards being created. It became a wild, wild west very soon because there was no real control, no real managed environment in terms of how to use data. But then things started to change. The big data year, the cloud came in. So we started moving how to use Tableau to kind of use these different technologies out there. And right now we're at the stage of how to get that quality, how to get that speed, and that's where we started thinking about some of the things that I was showing you earlier. Okay, scaling. There are two types of scaling I want to talk about here. The first type of scaling is just in terms of user productivity. Any data scientists over here? Okay. So in general, there's a talk that data scientists use about half the time. Oh, thank you. Half the time munging data, clean the data so that they can start using that for either analysis or running their model. I think that's a lot of time spent. And 50 to 80% of time just to do feature engineering is a ridiculous amount of time in my mind. So, and then everything after that too, it's slow for people with high skills. These are all operational things we should start thinking about how to kind of get rid of these operational costs. And while doing that, we want to get the performance, and also while doing that, we want to get quality control. While doing that, we want to get a user adoption as well. So these were the kind of biggest challenges that we faced when we got into redesigning our architecture, redesigning our platform. So we knew the problems. We want to get to a place where people are less thinking about clean data, less thinking about cleaning the data, but more thinking about what analysis they can do and how to get there. Another problem is dashboards. I think we talked about this. End questions, you're answering questions that dashboard was built for, but we wanted to get more. Like, it's great. Like Tableau, we can build beautiful, beautiful dashboards, and people like it. Like the one, we call this, sorry, again, I'm using the wrong button here. We call this the mustache dashboard, the yellow mustache. It's like a 9-12-5 report that comes out 9 in the morning, 12 noon, 5 p.m. to check whether our leads are coming on correctly. But it's got a great adoption. People look at it every day, make sure that we are in that band, the yellow mustache band. But then it's all limited. You are answering certain questions. We are not able to get people to ask more out of it. So, and that's why this is such an important aspect to building a self-service platform. Can you answer that N+1 question? I'm going to pause here because this is a real engineering aspect of self-service. If you can only answer the end questions that you got from the business user, that will never be a self-service environment, because there was always going to be one more question from that person who asked it. So if you're building an environment, build it for n+1. So that's one thing that was important for us to, that we realized when we were building this environment. I know these guys tell me, like, didn't we actually create this dashboard before? That's because that 3 months before, when the requirements came in, yeah, that was the most important thing. But in a couple of months, it changed. So we have to rebuild it again. We have to add more columns. We have to add more logic. That's where it comes to this repeatable self-service architecture. And we wanted to build something like Amazon Go. Have you guys heard about Amazon Go? Anybody? Cool. So Amazon Go is an experiment that Amazon is running in Seattle. And people are from Seattle. I'm assuming it's in Seattle, yes. It's such a rad, cool. I just cannot explain anything more than this. It's just like, there's no line. You go in there, grab and go. Grab whatever you want, and leave. I think that was pretty insane, the vision about how to do retail. But keep that in mind. Like, that's what we want to do, too, with data. We want to have people like, with executive presence or, directors, product managers. We want to have a space where people can just go in, grab what they want, and go. Without worrying about the quality of data, without worrying about the performance, without worrying about waiting, without worrying about getting in time from an analyst, we want to create an environment like this. And we had to do a couple of things. First, data, when we talk about data, especially website data, it's not clean. It's not structured. It's semi-structured at the best. There's a lot of things you need to do to the data to get to a point where we start analyzing it. And this is the first thing we did in terms of data collection instrumentation. So you kind of have to go back to your source. You have to go back to your source and figure out, is the source sending you junk? If the source is sending you junk, then there's a problem. So you have to kind of go there, and sometimes you have to put some kind of kind of filtering so that you start getting the right data. And this was very important for us because the product changed very fast. Our website, we're talking about the A/B testing, things like that. We create new products, in the same page, new products so that we can test out the performance. But every time they came up with a new product, what happened is, they'll break the data. Like, you have new types of data, you have new events coming in. So we were used to be in a point where you should have track all the clicks and swipes and check boxes and button clicks and everything. But then we didn't know what that means, though. Somebody, as an analyst, had to reverse engineer it. Oh, this page, that click, this means that user action. So the first step we took is we went back and, okay, we have to really stop doing that. We have to only get user actions. That's what matters. That's the only thing that matters. The user action, what actually user is doing. So I'm sure you guys have similar problems in terms of gathering data, instrumentation, whatever that is. But get as much context into data as early as possible. So now, if you go to the website, the tracking that we have is we look at view photo. People look at view photos. I read a review. I considered a car. I submitted a lead. These are things that are not changing. Whether it's using this platform versus the other platform, doesn't matter. It's always going to be a user action. That's what we're tracking. The second, I think this is the most important thing I want to talk about today, is this pipeline that we have here right now. I'll talk about how we used to do things before, and we still use it a lot. And how to create these dashboards, and how to do the reporting. There's always a pipeline. You have the raw data. You have cleansing rules. You create aggregate tables. You have reports with queries in it, business rules in it, and then you have this dashboard built. Let me ask you a question. How many people do this right now? The biggest problem with this is that it is stale the moment it's released. You're not going to have an extra question answered from this particular way of doing things. You have a set of questions. You can answer it, and people are happy. Most of the people are happy with it, but the learning stops from just that n number of questions. And from there, we want to go to this kind of a mode where you have raw data coming in, you store it in our S3 bucket, that's our data lake, and then you want to augment the data. When I say augment the data, keep in mind, the data still is at the lowest possible grain. We are not aggregating. We are not creating any cache layer. The data, we are processing the data. We process the data in the S3. We use whatever technology we want. We use Redshift, we use Spark, we use Intrana, whatever that is. We process data, pull it up, compute, push it down, store. That's the cycle. And you use whatever technology you want. You use whatever compute technology that you use. But then you use that, augment the data, push it back. And what happens is that means you're going to grow the data, not necessarily vertically, but horizontally. You're going to add more information into it. But that's OK. That is the good thing about cloud computing. You don't have to worry about storage anymore. Storage is cheap. You can store as much as you want. You have wide columnar structure that supports it. It's just CSV file or Parquet file. If you guys have not used Parquet yet, you should. That's where these kind of performance will start to you have the ability to get this kind of performance out. So once you start doing this, everything that we do, the data cleansing rules, the business rules, it's all going down to at the bottom, and you're augmenting the data every time. And now this data lives in S3 or lives in data lake and is accessible for everybody. Again, keep in mind, this is how we've solved the quality problem. The quality problem, because all these quality rules, whether it's a data cleansing rule or a business rule, all lives at the bottom of the lake, so that people who are fetching the data out of it is obviously getting the right data. Never a problem like, it's not a reporting problem anymore. It's a processing thing. You put the quality with the process. And you obviously have the right quality control checks, unit tests, things like that. But that's more of an engineering problem. What this means is, this is the self-service architecture or the platform is all about engineering the platform. It was never an engineering solution before. It was always a tool solution. You find the tool to solve the problem. And the biggest thing is that Tableau as a tool is amazing, but if you don't engineer the data underneath correctly, it doesn't matter. It doesn't matter whether you can solve it or not. So the key learning that we got is that, and we got engagement from Tableau, but for the self-service, we had to engineer the data correctly so that we can augment the data and people can get it, either for querying, either for an analysis, whatever. OK, so this is what happens. You have all these analysts writing their own queries to get insights out of it. We moved that to a data source. We augmented it. And now it's actually a point and click. So that's what I was actually showing earlier in the demo. You point and click, and to get to the Tableau and drag and drop insights, you're getting insights out of it right away. And tomorrow you have new business rules come in. The process that build these data sources are augmented. You have this changes all the time. You have business rules coming, change all the time. You have cleansing rule change all the time. But the idea is that, and as long as it's a continuous process, the augmented data gets improved all the time as well. OK. So analytics engineering, going from report development or BI development to analytics engineering. The few things that I want you guys to take out from this session is decouple the business rules from dashboard when you're thinking about self-service. Because self-service is not about dashboard. Self-service is all about data. So decouple the business rules. Rethink instrumentation. If you guys, especially if you're in the website industry, rethink the instrumentation side of this. And use the, get out of the way. I think that's another thing I want to talk about. Self-service is all about getting out of the way. so that people can get closer to data. They're not, most of the time, we slow ourselves down by creating blockers for people to get access to data. Whether it's an analyst or data scientist, basically the whole aspect is engineer the system and get out of the way, let them use it. So that, and build the quality into the engineering processes so that you can get the data to anybody who wants to get access to. And this is what we use for this, we call it last mile processing because it doesn't end. You're getting the raw data is great. That's data pipeline, that's data engineering, ETL, whatever you want to call it. But then it doesn't stop because we have all these business rules embedded into it before we can use the data. We call it the last mile processing, and we use serverless for this because that's the scale that we want to get. Now we have the data in the cloud. We have used compute. We decouple the compute. And then we use everything in the cloud to get this, whether it's Athena or Athena is something that we are still working on, and we are not completely there yet. But Redshift, we use a lot of Redshift. We use Spark to get to a place where Tableau can access the data through these, either it's a TDE or Hyper, which is coming soon. All right, so these are some of the major things I talked about. I think one key thing is response time is a big thing. If you want to have a successful self-service environment, you need to have an environment with a good response time. 8 seconds, maybe it's a push. Maybe the compute systems are not there yet, but it's not too far away too. There are technologies like Druid. I don't know whether you guys heard about it, but it can go through billions of records and to get access to this data fast, aggregate it on the fly, things like that, and put something like Tableau on top of it. That'll be amazing. But it's not too far away. That's what I'm trying to say. Another important aspect is this. We all heard about single source of truth. And it's funny, when we try to get a single source of truth, we kind of have a box and say, this is the only place we can get the data. It's the only way you can get data out. That never works. You restrict people to get the data out only certain ways. Redshift is the only place you have to go to get data out, or Netezza, or Teradata, whatever that is, right? And that will restrict the number of people who are using it. You don't get a data democratization. Yeah, you get data quality, you get control, but when you have put more control, you get less, data democratization. So the way to do this is, yes, single source of truth. Yeah, right. You want to have the data in your data lake that is clean and augmented, but that doesn't mean you have a single access point. Just give people access to the data in whatever technology that they want to, whether it's a Tableau, whether it's there's a notebook in Databricks, or whether it's a Jupyter notebook, or it's an R or Spark, whatever they want to. As long as they can come back to the same augmented data set, you have a clean data, and they can pick and choose the compute technology that they want to. And so I was talking about this. Modern BI is not about the tool that you pick. It's very important that you actually have the right tool. Like, I think Tableau worked great for us, but it's about engineering the experience. You can create a wild west experience in Tableau as well. We went through that. We had a problem where people were dragging from all over the place, but self-service and adoption comes in. You get a much better adoption when you have engineered your platform so that they are all getting the same access, same data, things like that. Okay, I'll take a pause right now. I'll take some questions. I know there's a lot of information. Yeah, please.
Whenever you change a business rule or data cleansing rule, do you just apply that back historically?
Yeah, I actually had this question before too once. Yes, we can. We couldn't do that before because we were kind of have this box of Redshift, and then we'll ask the engineering team, hey, can we actually reprocess data? They say, oh, it's going to take 3 weeks. That was not possible. But with the cloud, and that's where the performance of the cloud and decoupling the compute comes into picture, the data is there in the data lake. Now pick the compute, that will give you the answer. For example, Spark is a great example for that. We have Spark jobs. We just have to pick the right cluster size. Want to process for 1 year, we get a bigger cluster, I run it overnight, and shut it down once you're done. So, but we do. We go back and process data. So in general, we think that we know the business rules the best than any other tools. So we have engineers write their own code. So all these business rules are written in either Spark or Python or Java, things like that. We don't use an ETL tool. And then also the things that we will use, we would get easier access to people with general skills to continue to support it. That was the reasoning behind it. So we don't use any tools for getting these rules into the data. Yes. Right. Right. So the data source does all the things behind the scene. So once the Tableau user is connected, they don't see this as a fact table or dimension table. They see this as one place you can go. It's like let me put it like this: a big flat table for them, and they don't care about joins. That was one of the biggest problems for me as I was going through my experience the last 10 years. Like I really worried about the data model. I worried about the data architecture, but the end users really don't care whether they can join two big fact tables. I mean, I care about it. I care about the performance, but they don't. The end users really care about how to get the data. So a big flat table, big Excel spreadsheet works for them. That's the reason why Excel is great for most, a lot of people love Excel because they can do whatever they want. So to answer your question, all those things are happening underneath these augmented data source. So the joins are happening. We use Spark to join these big data sources, or Redshift most of the time right now, and we connect all this data together and push it up through the compute layer. That's right. So again, when I say flat, it doesn't have to be flat. So if you look at, you could completely use like JSON structure where it's not flat. You can have it structured that way, but most of our data sources are flat. But we use engineering resources to get those things done. Okay.
Maybe on top of that question, do you use data marts for specific departments? So you grab whatever data you have, either an engineer or if there's somebody in the business who knows how to write data marts.
Right. Okay. Great question. So the problem with data marts is we kind of moved away from the concept of data marts because there was a possibility that different rules. For example, how do you define a customer? That could be different for somebody in the marketing team. That could be different for somebody in the sales team, somebody in the product team, and we didn't want to do that. So we kind of went away from the concept of creating data marts. We would have a centralized place where we define everything, and the data source will be the same data source for the sales team or marketing team, whichever team that needs access to data. They will go to the same data source, and they have, we would create columns for them. They would use it. But the good thing is that now you can. Everybody, like, let's say I'm a sales manager. I am creating some analysis. I use the exact same data source as a product manager. So if I send my dashboard to a product manager, he knows exactly what I'm doing. He doesn't have to worry about difference in definitions, things like that.
So to elaborate more on that, so the sales group, marketing group, they're all exposed to the same data set?
Yes.
Or is it broken into A, B?
No. No, there is no restriction. I mean, that's probably because of us. We don't restrict any data to access to anybody, so we keep all access to everybody. Yeah?
So are you no longer doing the dimensional data modeling? There's no type 2 dimension or type 1 dimension? It's all flat data?
Good question. There is still dimension modeling happening, but that is not exposed to users. It's happening on the engineering level, and we have very geeky engineers who actually think about all these things. But as I said, keep in mind, guys, data democratization means different things. Self-service means different things to different people. And as I said initially, this is more about the real end users where they have no idea what we are talking about. We're talking about dimension model, snowflake structure, star schema, nothing. So that's all these things are happening still at the engineering level. We want to keep the data structured well, but we do have an augmenting process where we combine all these things together and give it to the users.
What's your ratio of live connections to extracts?
Okay, performance usually, that determines it. The live connection is where we are going. So we are picking up technologies that would give us because Hyper is probably going to change. I really wanted to have this presentation done using Hyper, but unfortunately I couldn't get it done in time. But hopefully we will. So soon, Hyper will solve some of these things, and we can use Hyper for it. Extracts doesn't scale to the level that we want to. It cannot support billions of records. We do have about 25 billion records. So the one that I was showing, the hope is to have about 25 billion records, and people can drag and drop and play around with data and do any analysis. That's kind of our goal. So right now, maybe more extracts, because we are still transitioning from the old way to do this new way of doing things. But live will be our preference with Hyper. Okay. Any other questions? Yeah.
So when it comes to self-service, you mentioned earlier that you have pods within different business sectors. Are those pods actually doing the self-service portion for the business requester, or is the business requester actually doing the analysis and the mock-ups?
Yeah, good question. So these squads, they're built in a way that these specialists are living within these business, the world of business. The hope is that we will slowly transition everybody in the squad to do it themselves. But right now, these analyst specialists, they are helping the people most of the time. But this is the thing. We keep it, this is pretty simple. It's not too complicated. Yeah, I get pushback from people to use self-service systems all the time. Like, when you have people tend to ask people for answers. They rely less on technology and less on tools. I have an analyst working on the side. I would rather turn my head and say, hey, what happened here? That's a general trend. But slowly, by having this, making it simple for people to get access to, slowly getting to a point where people can answer their own questions. Sorry, let me get this first.
Is there anything that you're really excited about from the devs on stage that you think will massively improve how you do things besides Hyper?
There are a lot of things I'm excited about. I'm just thinking which one. I think Hyper is, and especially in this self-service kind of a framework, Hyper is probably the most important thing. And one more thing I'm going to talk about a little after this is definitely Hyper for now. Okay, I'll take one last question maybe. Okay, cool, yeah.
So from what you described, I think it takes a lot of effort to get the data engineered. And that is the crux of what you said is the value. Once that is in place, then everything else is seamless. What did you do to get that, and what was the effort involved in getting that layer set up?
Yeah.
Give us some idea of the size also.
Yeah. Right. We're talking about taking all the BI developers or Tableau developers or MicroStrategy developers and making them an engineering unit. So their focus, when we kind of look at their skills and train them, we're focusing mostly on the engineering side of things rather than report. We didn't want them to be just focused on building dashboards. I think that was the main difference. We had to re-engineer a lot of our scripts and things like that. So we're talking about 70 scripts. It's a big change. This whole idea of data sources was a big change in general. We have resources were stacked towards engineering more than BI development. That was the biggest change.
Then you architected all that right from the ground up?
Yeah, 2017, that's what we did. We, starting from the beginning, there was a change in the way we did, we changed a lot of things. The website changed too, so we used that opportunity to kind of redesign our data platform as well. All right, one last slide. This is where I think that technology is going, the BI technology is going in general. If you have not thought about serverless is where everything is going. BI will go there too. Hyper is probably the first step towards serverless. Keep in mind, we are bringing data closer to insights. And Hyper is probably the closest that I have seen so far, where the data lives inside the server where there will be BI. I think that's where the BI technologies are going in general. If we can pick and choose a technology that you want to use, choose always whenever we have a serverless. And so cloud is important for that. You have to get your data into the cloud first, and then you pick a technology that is focused on serverless compute. A couple of other things, I think advanced analysis packages like Amazon AWS machine learning packages. You have TensorFlow, things like that. These are all will be automated soon. A lot of data sciencey kind of functionality will be applied into the BI. So these are all coming, and I think some of the things that the dev on stage, you can probably hear about some of the things happening as well. The biggest thing in my mind is the win that we got is first adoption was great, but slowly and slowly we're starting to see that people are learning more than we used to. We're talking about data more. We're talking about insights more. And we see people like, it was a great example where a product manager started talking about p-value. That would never have happened about 4 or 5 years back. We're talking about p-value and statistics because now we have access to the data, we have access to the statistics dashboard, we have access to insights much more easy than we used to have in 4 or 5 years back. So it's limitless. Once you have a clean access to data and have technology and tool opened up to people, I think limitless is the one word that comes to my mind. Go back. One thing I would love you guys to go back and think about is do you guys have the right strategy for data, right strategy for engineering, right strategy for your self-service analytics? It's something that excites me. So you can reach out to me anytime to talk about it. Thank you, everybody.